Good afternoon and welcome to 2026. Who even thought we would still be alive in 2026 when we were little kids, right? So happy New Year to everyone, and this is our first Data Research Seminars, and it's a great pleasure to have Professor Chris Atkinson. I think you all know who he is, and couldn't think of a better qualified person to launch our seminar series for this year and to speak to us about the state of the automotive industry. Have at it, Chris. Thank you for joining.
Thank you. And
Thank you.
Good afternoon, everybody. Just a word of warning, some of this you'll have seen before if you've seen any of my other presentations, but at least half of it is new, I would like to think. The state of the automotive industry in 2026, right? The US automotive industry is navigating a high stakes transition in the remote presentation from its traditional hardware centric manufacturing base.
Sorry, Chris. I joined to confirm. Right now, the screen is not being shared.
No.
Yeah, so the slides aren't being shared with the remote audience.
Can somebody who's able to come and help me?
I'm the expert, but I think having.
So it was set up in the belief that it.
Are you in the meeting in that workstation?
Yes, I signed into the meeting.
I think we just need to share the screen then from there. Apologize, interrupting, but
Thank you.
No, but thanks for checking.
Needs to be-
Great.
Was sharing this.
Right.
So there. Here's.
all right, I'm now seeing your desktop.
Right, now we gotta find, there we go.
There's. What are we seeing on the screen? Okay, Greg, are you seeing it?
I'm on a bit of a lag. No, I'm not seeing it. I'm still seeing the desktop as opposed to your screen. Is there multiple screens here?
Wanna,
Yeah, you need to step back.
you wanna help?
It was working earlier. To add that to everybody. So what's changed? No idea.
You're better at this one.
Yeah, it seems like we're sharing this screen. I'm
Yeah.
assuming, yeah, that's the problem. All right, so stop sharing. Let me go ahead and share. Now the audience should be coming across here in a second. Okay, and then when we
Set that to
presentation mode.
presentation mode. Yep.
Oh,
Oh, there
there
it
it
is.
is. All right.
Okay, there we go. Thank you very much. Okay, so the US automotive industry is undergoing a high stakes transition. I've given you this little summary here from a traditional hardware centric to software defined mobility. But it has to simultaneously manage all of the cost pressures, the supply chain instability, and shifting regulatory expectations, right? A huge task. What are the things I'm going to talk about today? They are vehicle affordability. Why? Because you've heard about that a lot recently. It's been decades since the average American worker has been able to afford the average new vehicle. Right? So the average person does not buy a new vehicle. But it has a deleterious effect on the existing and potentially the future vehicle fleet. And I'll get into that in more detail in a while. Software-defined vehicles, SDVs, are the future. So we've been through sort of conventional vehicles, EVs, AVs, but software-defined vehicles, SDVs, are the future of mobility. And all of you, I have the expectation that all of you at some point or another will work in the mobility industry, and SDVs are the future. So we need to take that into account. But there's a resultant electronics fragility. We know this because we've been through the pandemic and we've been through shortages of electronic components. And it's going to happen again. It's going to happen again for at least two reasons, which I'll talk about. We've spoken in the past about EV supply chains, critical materials, and battery materials. I'll bring them up again because it's incredibly important, but only very briefly. We'll talk about AVs, autonomy, and advanced driver assist systems. China's rise as a major vehicle exporter has been remarkable over the last 10 years. We'll talk more about that. So there are many challenges on many fronts for the future of the US automotive industry. But if you need to take comfort from one thing, and that is the US automotive industry has forever, the default state is crisis, if not chaos, right? That's the default state. So this is nothing new. These are the areas I'm going to talk about. You've seen this slide probably before, but it's been updated. We now in the US drive 104,000 miles every second of every day of the year, 104,000 miles every second. We consume 6,100 gallons of combination of diesel and gasoline every second. So you see the trailer in the lower right-hand corner there, an 18-wheeler, that's a 10,000 gallon trailer. Once every 1.5 seconds, one of those couples up to a fuel system. Right? It's not strictly true because some fuel is pipeline, but you can think of it in that way. Diesel and gasoline consumption. I apologize for the fuzziness here on the left-hand side. That's gasoline consumption and that's diesel. All you need to know is it's been remarkably flat in the United States for the past 30 years. 30 years, remarkably flat. Even as vehicle miles traveled, it has increased. Why? Because vehicles have become significantly more efficient. On the right-hand side, these are the inflation-adjusted prices of gasoline and diesel. And essentially, again, you don't need to see the details other than to know it varies between $1 and $4 a gallon, but has been remarkably consistent across the last 30 years. So on an inflation-adjusted basis. What are the successes of the automotive industry? Criteria pollutants, so CO, NOx, SOx, particulate matter, hydrocarbons, radical decreases up to 90%, 90% or beyond in some cases. The only thing that has increased over time, of course, is CO2 emissions, because CO2 emissions are inescapable if you use hydrocarbon fuels. But every other criteria pollutant emissions remarkably decreased. And that obviously is incredibly good for urban air quality and ambient air quality. You've seen this before, but it bears repeating again. 2018, the United States became a net energy exporter for the first time in its history. We, the old people in the room, fought for 50 years for energy independence. We achieved it in 2018. Economics and vehicle affordability, okay? Vehicle miles traveled per capita, about 9,600 in the 9,000 to 10,000 miles per year range. Average age of US passenger vehicles has increased significantly over the last 20 years. And this is from 2020 to 2025. This says 12.8. It depends on who you speak to, but it's roughly in the 11 or 12-year timeframe. And I'll point out to you later, this is a very, very bad thing for many reasons. Real US GDP per capita has increased. Vehicle price versus household income. That's the issue, is the affordability of new vehicles. SUV share of new vehicle sales was 50%. The average auto loan interest rate is over 7% currently. The average vehicle price as a percent of median household income is 60%. So the median household income is $88,000 in the United States for a household. And the average vehicle price is about $50,000. And that's roughly 59% or so. EV sales versus long-term targets. These are Biden era targets to 100% by 2040. We're still at 9%. There's an extra data point there for 2025. This is flatlined entirely. Okay. VMT, vehicle miles traveled in trillion miles per year in the United States. They've increased significantly, doubled in the last 40 years. You can see the dip due to the pandemic. And then last year, we went back to 2019 VMT. So we're back at pre-pandemic VMT in the United States. Why the fascination with VMT? Well, because vehicles retire out of the fleet on the basis of their total vehicle miles traveled. And so if you're going to work for the automotive industry or on behalf of it, you're interested in new vehicle sales. And so VMT is a direct indicator of vehicle sales. In 2024, $29 trillion GDP, 3.28 trillion mile VMT. So it turns out to be $8.90 of GDP per vehicle mile traveled. You've heard me say this, some of you have at least. If you want, I don't drink coffee, but I believe that very fancy cups of coffee at Starbucks are of the order of $7 or something like that. If you wish to create that much of GDP, somebody has to drive a mile. If you wish to create another one, somebody has to drive another mile. Compared to 1980, in so-called chained dollars, it's $7.32 a mile in 2024, back in 1980. So in 44 years, we've seen an efficiency improvement of 22% compounded, which is about 0.4% year over year. So in other words, the economic efficiency of our economy as a function of vehicle miles traveled has improved by 0.4% per year. In other words, it hasn't improved at all, first order. In other words, we are as dependent upon driving as we were in 1980. And this wasn't supposed to happen. We were supposed to have this thing called the internet. Even before work from home, the internet was supposed to revolutionize the way in which we worked, the way in which the economy worked, such that we would generate more dollars per unit physical things that we did. One of the physical things that we do is drive, and it hasn't happened. Does everyone understand what I'm saying? It's a convoluted argument. But what it says is that from a transportation point of view, ignoring transportation, our lives have been transformed over the last 40 years. We now sit in front of laptops and do things. But transportation has not been affected one iota by that. Stayed the same. Light duty vehicle sales, $17 million in a normal year before 2008, the global financial crisis, struggled to get back. Was at 17 million a year, roughly speaking, bumping around for a few years. And then the pandemic hit. And now we're back to some sort of a new normal of about 16 million. This is terrible for many reasons. One of which is that the automotive industry isn't selling as many vehicles. But the second thing is this: vehicle safety. I'll talk more about that. And vehicle emissions and vehicle fuel economy. The longer we keep old vehicles, and we're keeping them longer and longer for two reasons at least, which I'll get into. The longer we keep them, the worse the vehicle fleet safety is, worse the tailpipe emissions are, and worse the fuel economy compared to what it could be. We've lost 13 million new vehicle sales since 2019. That's 650 billion with a B in total new vehicle sales have been lost in the United States in 5 years. That's terrible for the vehicle fleet. It's terrible for the industry. It's terrible for everyone. Trade tariffs. This is a scenario one of the OEMs came up with, that for the total US new vehicle fleet would be of the order of $2,000 to $3,000 per vehicle. As you know, the new vehicle price is $50,000, roughly speaking, almost exactly. So you're talking about 5 to 6%, 5 to 6.5% of the cost of a new vehicle. There's the percentage increases there. Very, very bad thing. This is the vehicle affordability index. Again, this is the number of weeks that the average US household has to work without any other expenses and without taxation in order to be able to afford the average vehicle. Shown this, inflation has risen significantly, yes, but the average new vehicle price has outstripped inflation since 2010 or so. This is remarkable. The new vehicle loans, 20%, a full 20% have more than $1,000 a month payment. Just for the new vehicle alone, doesn't include every other expense. Used vehicle loans in a similar boat. So what happens as a result? Well, one of the things happens is that people keep their vehicles longer, right? They're induced to keep them longer. And vehicles last longer because they're significantly better today than they were 20 or 40 years ago from a reliability point of view. But what you can see is the significant divergence, right? light trucks, cars, and the combined fleet. The combined fleet is there, but people keep cars longer. And that's not necessarily a good thing for several reasons. One of which is that they're keeping them longer because they are cars. In other words, because they tend to fall on the lower end, the lower cost end of the spectrum. These are the ones that people cling on to more, longer than they should. Whereas for sport utilities and light trucks, these are sold to a more affluent clientele, and they keep them for significantly less. Bear in mind, this is vehicles that have sort of a first life, a second life, and potentially a third life that spans an average of 11 years. Okay, so bear that in mind. 11 to 13 years. Remember that number. That's the average. NHTSA, the National Highway Traffic Safety Administration of the US DOT, has done for a number of years these current yearly travel, survivability, probability, and weighted yearly travel as a function of passenger car vehicle age. So from any vehicle from 1 to 20 years old, this is the estimated survivability, meaning 0.5% of new vehicles exit the vehicle fleet in their first year of operation, most notably due to accidents or something else, crashes, something else, right? And you can see it drops down to at year 11, year 12, year 12 and 13, you're down to 1/2 of the vehicle fleet still remains, which corresponds roughly with the average or the median age of the population. The weighted average travel is 13,000 miles per year when they're brand new, down to 500 or so miles when they're 20 years old, right? Old vehicles are unreliable and nasty and horrible, and the people who own them don't travel very far on those vehicles. Lifetime vehicle travel, miles traveled 126,000 on average, right? So two things. The 20-year-old vehicles in the fleet today, only 8% of the ones that were originally sold in that model year 20 years ago still live, right? And they only do roughly 500 miles a year. But bear those two numbers in mind as well. Okay, I said safety. Road traffic safety is a terrible, terrible issue in the United States, as you've heard me say in the past. Truly an existential crisis. Over 40,000 highway fatalities in the United States every year, right? In 26 years, we will have killed over 1 million Americans. 1 million. 26 years. This is a truly existential crisis. You can see the numbers improved modestly over the last couple of years. In the beginning of the pandemic, there was a fairly big spike up, improved modestly, but modestly is the key. So people have said, I've said to people, we need a new vehicle fleet because it improves the safety. It's intuitive. It's intuitive. They say, but prove it. You need to do more than try and snow us with intuition. Prove it, right? So if you go into the NHTSA fatality and injury reporting system tool known as FIRST, you can interrogate it. You can say, what I did was I said in 2020, which is the most recent year for which full statistics are available, 2023. I said in 2023, there were a number of fatal crashes, right, involving, and this is per vehicle. This is not per fatality. This is per vehicle. But there's a correspondence between the number of vehicles involved in the fatal crash and the number of fatalities. I'll show that to you in a while. It said of the vehicles that crashed, were involved in a fatal crash in 2023, how many were 2022 model year, 2021, 2020, all the way back to the year 2000 and before. So in other words, how many 2000 year model vehicles were involved in a fatal crash in 2023? That's what I want to know. And these are the numbers. These are the composite numbers. And you can see here, these are the number of total fatal crashes, but these are the number of fatalities, which means there are 0.8 roughly fatalities per vehicle involved in a fatal crash, meaning on average there's 1.25 vehicles are involved in a single fatality. Some of them are single vehicle crashes, others are two vehicles running into each other, and so on and so forth, right? This is interrogating the database, saying, and it's all 2023, it's a single year only, right? It says in 2023, how many 2023 model year vehicles were involved in a fatal crash? how many 2022 model year, 2021, 2019, 18, and so on and so forth. All the way back to 1999. How many 1999 model year vehicles were involved? And you can see it drops off somewhat. This is interesting, this increase here. 2008, remember that there was a significant drop in new vehicle sales due to the global financial crisis, and it's somewhat reflected in there. But you can say, okay, well, it's not too bad. 1999 vehicles are involved. What's that? 1/4 the amount of, in 1/4 the number of fatal accidents as these vehicles here. But bear in mind two things. One of which is that there's only 8% of these vehicles remain. Right? So that immediately ups this proportion by a factor of 10. And then they only do 500 miles a year. So what's that data look like? As a function of vehicle age, what is the likelihood of a vehicle being involved in a fatal crash by vehicle age? Going back, so these are 2023 vehicles being involved in a 2023 fatal crash. It's made it relative, so it's a factor of 1. It only goes up above 2 at the vehicle average age of the vehicle fleet. In other words, if you have a vehicle that's 11 years old or less, it's only ever, at worst, twice as likely to be involved in a fatal accident as a brand new vehicle. Only twice. But you can see this tail here rises dramatically to where the fact in 20 years of age, it's 10 times as likely, 10 times as likely on an individual vehicle basis. But when you look at VMT, 10 times on a vehicle basis is 25 times on a VMT basis. And the composite of that is a 20-year-old vehicle is 250 times more likely a per mile basis to be involved in a fatal crash than a brand new vehicle. 250 times more likely. That's absolutely scandalous. And why? Because there's technology, there's the level of passive and active safety inherent in the vehicle. I need to draw a couple of things to your attention, one of which is the actual cause of the fatality. We're not breaking that out. This is all fatality. So it might be a single vehicle rollover, it might be a single vehicle collision, it might be 2 vehicles colliding, it might be a single vehicle killing a pedestrian or a cyclist. All of that, they're all considered together, right? But there's technology, the level of passive and active safety on the vehicles improves radically with time, which you can see here. The vehicle condition degradation due to age. In other words, something could fail on the vehicle. The brakes could fail, the steering could fail, the wheel could fall off. Then there's the level of maintenance. Even if the wheel stays on, it could be bald tires, who knows. I would posit to you that a 20-year-old vehicle on average is more likely to have bald tires than a 1-year-old vehicle. And then, of course, there's human factors that are implicit in this as well. Driver behavior, driver capability, and other reasons. We don't know what these other reasons are. There's a whole host of potential reasons. But long story short, I'm telling you, if there's one thing you should take away from this talk today, is don't drive in any vehicle that's older than 10 years old. Simply don't, because you're taking your life into your own hands. You're 250 times more likely on a per VMT basis to be involved in a fatal accident. And again, we knew this intuitively, but I, for the first time after many years of saying this, people have said, prove it, and here it is. Okay, I spoke about emissions degradation, and this is from vehicle remote sensing in both Colorado and Virginia. And you can see that over 20 or so model years, here we are, 20 or so model years, what are we looking at? NO increases by a factor of about 10, hydrocarbons increase by a factor of about 3 or 4, and CO emissions increase by about a factor of 3 or so. Again, merely proving what you already intuitively know, which is that older vehicles are higher emitters. Then back here, this is data from, again, from NHTSA showing average new light duty vehicle fuel economy, things that you know, right? Which is that new vehicles are significantly more fuel efficient than old ones. So I hope I've proved to you a couple of things. One of which is that an older vehicle, if you make the vehicle fleet older than it ordinarily would be, by not selling as many new vehicles, you make it less safe, higher emitting, and higher fuel consumption. So we need fleet turnover. It's essential for improving individual vehicle and hence overall vehicle fleet safety, reducing criteria pollutant emissions, improving fuel efficiency. So the solution is straightforward. Get rid of all old vehicles, where old means over about 10 to 13 years, and then you've given an engineer a job. The automotive industry. Okay, software-defined vehicles. You're not going to be able to read this, but this is remarkable. I found this recently, Giorgio. It's chemical and
1977.
used from 1977. Okay. Saying microprocessor use in cars projected to grow. Coming to grips with the microprocessor was a major item of business at the 1977 Society of Automotive Engineers International Engineering Congress and Exposition in Detroit last week. Consensus of automotive engineers projects the introduction in the near future of the small onboard electronic computer to perform many of the regulatory functions associated with vehicle operation. Some of these are already being used in the ignition control and anti-skid control of braking systems. Uses generally cited relate to greater vehicle safety, lower fuel consumption, lower engine emissions, lower engine pollution, and higher automotive reliability. We use the same things every day. An onboard computer, for example, could determine continuously the optimum fuel-air ratio in response to engine temperature, engine speed, and load conditions. Similarly, the computer in principle could limit the amounts and kinds of pollution and engine exhaust through appropriate engine control. Two general approaches are being considered. One is for a separate system for each control function, and the second is for an integrated system with more sophisticated and more expensive. They mentioned Bosch. 1977, so we are 50 years into electronic engine control, and we're now talking about the electronics being 45%, or close to one half of the value of a new vehicle. This started in 1977 with a single, here it is, the 1980s, engine controllers down here. And now we have advanced driver assistance systems, body and security, connectivity, engine controllers, passive safety, active safety. Engine controllers have been there all along. But we're talking about 100 discrete microprocessors on the top end vehicle. 100, up from one 50 years ago, up from one. And 100 million lines of code. Intel and others are now talking about, well, we have thousands of semiconductors, right? So we have little logic things and 50-cent semiconductors for logics and gates and all of that stuff, but hundreds of CPUs and GPUs, etc. Trending towards systems on a chip and something called chiplets. I hadn't heard of those, but there they are. A lot of use of AI, including end-to-end AI for powertrain control, vision and perception for both ADAS and advanced driving systems or AVs, path planning and localization for AVs. This is an Intel picture showing central compute, Ethernet, connectivity, L4 automation, batteries, EV power. This was from 2026. This is from last month. It's not an old thing. And then this was from, I can't remember who this is from. That might be NVIDIA. No, ARM. It's from ARM. There you go. Back in 2025, ARM Compute Systems. So MCU, zonal controllers, vision, cockpit, ADAS, AVs. All I'm trying to point out here is that there's a proliferation of microprocessors on board vehicles. And immediately then we start thinking, this crossed my screen some time ago, is the data center value chain. And it shows Intel, AMD, NVIDIA, a whole bunch of others, right? The issue here that we have, Schneider, issue here that we have is that the automotive industry is now competing with the data center industry for microprocessors. That's a terrible thing. The data centers can afford to pay 2 to 5 times more than the automotive industry can for exactly the same silicon. So there's the potential for the automotive industry to be crowded out completely. You might find this of interest. These are increased projections of data center power in the United States. By 2035, which is 9 or 8 years hence, 80 gigawatts of new power generation. This is a 1 gigawatt natural gas fired power plant. So we need 80 more of these in the next 8 years. It's essentially one a month. And while China builds that regularly, the United States simply doesn't. So we're in serious jeopardy. Currently, this is another stunning piece of information. The state of Virginia, where I lived for 6 years, 26% of electrical power is used by data centers. About 8% across the United States, but it's 26%. So Caterpillar is now selling 700 3-megawatt natural gas compressors at a time, natural gas generators at a time to data centers. Utah is going to need 1/4 the power the entire state currently uses for a single data center. So, long story short, data centers, as you read about, $1 trillion of investment is going to go into that. And they compete with the automotive industry, not for these engines by any means, but they compete for engineering, parts, materials, and most critically for semiconductors and microprocessors. EVs, future of electrification is not here yet, it's decades away. We have to resolve various critical materials and materials supply issues. Probably seen these slides. To electrify all VMT would add 43% to US annual electrical energy demand. It's an industry that typically increases between 1% and 3% per year, has done for the last 50 years or so, since the 1950s, but would require 43%. So obviously it would ramp up over time. This is a prodigious amount. Again, direct competition today with data centers. Supply chains, I've shown this before, but it hasn't got improved at all, right? The red is China. Its left-hand side is production, right-hand side is demand. Take copper, for example. China produces 50% or so, but has a demand for 60% or so. The only one that's disjointed is, this is Indonesia. Indonesia is now the world's largest producer of nickel by a long way. This demand is small. But you can see that every other one, from rare earth elements to graphite to cobalt to nickel to lithium to copper, where copper and rare earths are absolutely critical for electrification across all scales, completely dominated by China. This is another plot showing critical materials with a high supply risk, very highly important to energy supply. And the things you know, lithium, nickel, all of the rare earths, and then things like cobalt, graphite, silicon carbide, magnesium, platinum, etc. And again, on the right-hand side, all the red is China. This is Indonesia again for the nickel. And to what end? Well, you've seen this before as well, probably, which is greenhouse gas emissions. How do you minimize greenhouse gas emissions for a given amount of critical materials? And in this case, battery materials. And the answer is, for your fleet, you can either concentrate all of that material in a single BEV, you can spread it out amongst a few plug-in hybrids, or you can spread it out amongst a lot more mild or strong hybrids, but without the plug-in capability. And which of those gives you the lowest CO2 emissions for that vehicle fleet, assuming it does a certain distance in a particular year? And the answer is, again, what your intuition would say, which is hybrids, because you get the best fuel efficiency improvements per vehicle, per amount of critical materials. So we're seeing a reversion to engines and hybridization. We're seeing this move away from the policy-led electrification of all vehicles, EVs. We're now seeing hybridization. That, of course, means increased electrification as well, but new engine architectures, ultra-high efficiency after treatment, AI and ML-based engine and after treatment control. Wonderful new application, well, not a new application, 30-year-old application, but an excellent thing to do. And then, of course, V2X technology. AVs. ADAS versus ADS, connectivity is requirement, automation. How safe is safe enough? We haven't answered that question. It's not clear that we're going to answer that question before we see the significant rollout of AVs. You've got to worry about the risk and severity of failures. The N+1 problem is the one where you can say there's a certain likelihood of the vehicle doing X, Y, or Z, but there's always one new problem lurking beyond that that you haven't uncovered. N+1 problem. Then how do you test and validate these vehicles? Automation versus ADAS. I showed this picture last time, and it can fail miserably. This is GM Cruise. GM dissolved Cruise, as you know, but not before running into the back of buses, stopping in wet concrete, being unable to realize whether the truck was turning in front of them, being stuck in a work zone and running into a fire truck. But incredibly difficult to get right. But somebody seems to have pretty much got them right, and that's Waymo. 127 million rider-only miles. September 2020. 127 million. Who's been in a Waymo? Yeah, Chris. Yeah. None of the rest of you have. I said this to you last year, and you need to take it seriously. You all need to get on a plane this weekend and fly to Phoenix or San Fran. Now you can go to LA or San Francisco or Austin, Texas, and travel. And because you spent the airfare, you can spend all weekend traveling around. But it's a remarkable experience. It'll change your life. Really will. 127 million rider-only miles. Remember that 3.28 trillion vehicle miles VMT and about 40,000 fatalities in the United States every year. It means one fatality every 80 million miles, right? Which means that Waymo should have seen 1.5 fatalities. It hasn't, like it's seen 0. But if your average Waymo was your average American driver, and you now know, everybody in the room now knows, vehicle age, and per VMT, there's this horrible sharp exponential increase. So Waymo is crowing about how many fewer fatalities and 90% fewer serious injury or worse crashes. Okay. They're saying they are better than the average driver. They are. They are better than the average driver, but they're in brand new vehicles. This needs to be compared with my datum of 1, not my datum of 250 times. You follow what I'm saying? So the next time that someone crows to you about how wonderful AVs are, say, yes, but they are brand new vehicles, and they'll be completely confused because they're fixating on the driver, or the lack of driver. I'm fixating on the quality of the vehicle, regardless of whether or not it has a driver in it. Right. China as an automotive industry powerhouse. The world now produces 93 million vehicles, or did in 2023. Fully 1/3 of those are produced. Fully 1/3, right? The US is second, Japan third. You can see the drop off here. China car production went from 1% of the total world number to 39%. It's not 39%, it's 30%. I don't know. Bloomberg contrasted. In 25 years. Just an absolutely incredible improvement. And then Chinese EVs, massive increase in numbers. This is the issue though. These are Chinese brands in China. These are foreign brands in China. And this is between 2023, across 2 years, these are the cost reductions, the price reductions that they saw. BYD, 35% reduction in the sticker price of their vehicles, 35%. And why? It's not because of efficiency of production, although that comes into play, because they locked in an incredible price war within China themselves. To the extent that the Chinese government has stepped in and said, stop doing this, but they haven't stopped doing it. They continue to increase. So what has to happen is that the Western brands have to keep reducing their prices in sympathy, otherwise they simply won't sell any vehicles in China. So what you're seeing here is an automotive industry in China essentially eating itself. EV exports from nothing in 2019 increased 160-fold in 5 years. And I said this last year, but solar PV is a case study. There was a time where we said we would never drop below $1 per watt. $1 per watt, it was impossible for anybody to produce a solar panel below $1 per watt. They are now in China at the factory gate, they're at 5 cents a watt. 5 cents a watt. 400-watt panel, which is this big by that big. Beautiful. If you've ever seen a brand new one, it's absolutely gorgeous piece of equipment. $10. $10 a piece at the factory gate. And it's below the cost of materials. How the hell is that possible? Well, it's possible for a number of reasons. One of which is that all of these industries are heavily supported, not necessarily by the central government, but by regional and local governments. Why? Because they employ large numbers of people and they pay taxes and so on and so on. So this is monthly exports of solar panels to the rest of the world, increasing enormously from China, even while the price just plummets. And so no one can compete. No one can compete against this because you're competing in a completely lopsided field. Battery production is similar. You know, they said $100 per kilowatt hour at the pack level is what they used to say. And we're well below that in China now, well below. And they can sell below the cost of materials, so there is no price floor. So if you are trying to compete against Chinese manufactured battery packs, if not solar, forget it, you can't do it. There's nowhere in hell anyone in the West can do it. Okay, so the US automotive industry drivers, EVs since 2010, it was a policy-driven transformation, And if there's one thing we've learned about policy is it can be reversed overnight. And this was reversed overnight a little over a year ago. Completely reversed overnight. So everybody threw everything they could at electrification. Why? Because US and Western CEOs of automotive companies can think of one thing at a time only. They're incapable of thinking of anything more than one. So they were told by their management consultants, this is what you got to do. This is the way of the future. You have to pour everything you can possibly do into it. And they believed it. And they took that hook, line, and sinker, as they say. Right? And you can see what's happened now. An unmitigated disaster. AVs have been technology driven, AI is technology driven, but it's non-automotive specific, meaning AVs are automotive specific, right? They are cars, they have 4 wheels, right? But AI, you can use that anyway. Software defined vehicles will be the next wave, and this is technology driven, technology software intensive ADAS. And it's greater than AVs alone, because we'll be selling software defined vehicles that are still human driver assisted at least. So they'll have heavy amounts of AV capability and ADAS capability. US policy and regulation. What if we deregulate fuel economy? What if fuel economy goes out the window as a requirement? Well, you're already seeing that. People at BMW and Mercedes both now have V8s, saying they will never produce another V8 in their lives. They are now, as of today, this very day, producing new generations of V8s. And of course, the Detroit 3 are now producing many V8s. What does that do to the industry? We don't know. Our trade policy is punish our allies, disregard existing supply chain and trade, and impose tariffs. But US automakers are some of the biggest importers. GM imports 1.2 million vehicles a year, right? Vast majority from Mexico and Canada, but they're a vehicle importer. So we are punishing our own companies. Sergio Marchioni, I showed this last time. He said, this is in 2015, so this is fully 11 years old. He said, the industry as it was structured, the automotive industry was the world's greatest destroyer of capital and unsustainable. He said there's redundant investment, structurally low returns, unsustainable costs, and his solution was industry consolidation. OEMs now have 6 or 7% return on 6 or 7% total return. So in other words, if they earn $100 billion a year, 100 billion in revenue, of that 6 or 7 billion actually be profit. And look at this, Mercedes-Benz and BMW, 2025 are now 5%. You have to feel sorry for those people. Recent multi-billion-dollar failures on the part of the automotive OEMs. This is a new slide, Georgia. I came up with sort of a rogues gallery of everything that the OEMs have done wrong in the last 15 years. They invested massively in mobility as a service in the 2010s, including subscription services and shared vehicles and shared rides, e-scooters and shuttles, all gone. Puff, all of that money gone. Six Sigma, we won't even talk about that. Overinvestments in EVs, probably $50 to $100 billion. Overinvestments and too early investments in AVs. GM, Cruise, they just backed out. They just lost their total investment in Cruise. Failure to see supply chain issues around single sourcing of semiconductors and microprocessors exposed during COVID. We're still seeing that. We're going to continue to see it. And now we have data centers to compete. And they can pay anything. They will pay anything for electrical power. They'll pay anything for hardware. By anything, I mean 2, 3, 4, 5, 10 times what other people do. So how are you going to compete against them? I have no idea. We continue to have reliance on single points of supply. Ford and aluminum, again and again and again. They keep having fires at their suppliers, and then they can't produce vehicles and they can't sell them. Just when the market wishes to buy their vehicles, they can't produce them. The fallacy of just-in-time or lean manufacturing. This is the greatest thing that ever happened out of COVID, to my mind. Because I hated just-in-time, because lean manufacturing. It was invented at MIT. I'm an MIT graduate. Complete and utter fallacious. It's built on a fallacy and it was exposed to be so. Toyota, who pioneered it in the 1990s, in the pandemic, just quietly abandoned it entirely. This is the most recent scandal. This sort of strikes closer to home. Forced retirements of senior engineering staff post-pandemic. And they're now relying on the same technologies that these engineers developed 10 and 20 years ago.
But they're all gone.
They're all gone. The thing, Georgia, is how many times can you make stupid decisions? And the answer is, in the automotive industry, semi-infinite number. Okay, so in the medium terms, I said this earlier, OEM average margins of 5 to 10%. Tariffs of 25%. You can't impose a tariff at 25% on a vehicle when the OEM is making 5%. Okay. The automotive industry has survived the global financial crisis, the COVID pandemic, survived semiconductor shortages and more. How will it survive this latest catastrophe, which is the self-imposed tariff war? We seem to be edging away from tariff wars, but it's not altogether clear. Okay, so the automotive industry in the long term, I didn't change that. And from a long-term point of view, we're seeing more electrification, including hybridization, more connectivity, more data, more automation. Affordability is a huge issue. You've heard this. Even the president, who denies that it's even a word, talks about it, right? But it comes down to safety, 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 as well as vehicle fuel efficiency and criteria of emission. But this is obviously, this is my latest bugbear. It has been for the last 5 years or so. Vehicle automation, software proliferation, manufacturing, engineering skills. There's new areas for automotive OEMs. You've seen this, right? Every major of the 5 top eVTOL companies, they all have an automotive partner. Isn't that amazing? Shows you 2 things. One of which is that nobody knows manufacturing like the automotive industry. And the world is now acknowledging that, number 1. Number 2 is many of the technologies are similar, especially with respect to electrification. And Renault in France is now producing drones. Okay, macroeconomic trends, it's the economy stupid, new vehicle affordability is key. Full vehicle electrification is decades away, but HEVs and plug-in hybrids are no longer being discredited. Autonomous vehicles are here and now in limited operational design domains, but tens of millions of rides to date. Remarkable, remarkable. But remember this, my talk. Waymo, 127 million miles driving. If that had been the average US driver, would have seen, to use the term, 1.5 fatalities. So statistically speaking, you can't say they are safer than even the average driver. And you now know that it's not simply the driver, it's the driver in the vehicle. And it's the newness of the vehicle, it's the modernity of the vehicle that has an incredible effect on whether it's going to be involved in the package. So yes, it's driven by somebody other than a human. Yes, that's amazing. Yes, it's miraculous. Go and sit in one of them and see the steering wheel move as it drives down through the streets of Phoenix like I did. But there is also there are other technologies on board that vehicle that make it safer than the average. Software-defined vehicles, supply chain, China focus, try to compete at your peril. The lesson of the automotive industry is one of survival. And then I'll pull this up. This will ring true to you. Talking about the aging of Japan's automotive industry. In 1983, and you read this in the Wall Street, in the New York Times, and it says, there are these little manufacturers in Japan that will never survive. They won't survive the rest of the decade. And their names are Subaru, Mazda, and Mitsubishi. Guess what? Still fine. They're still here. I bet you there's more than one Mazda and Mitsubishi, Subaru out in the parking lot. Who owns one of those vehicles? There you
got
go.
a Subaru there for sure.
Yeah, there you go. And they were supposed to be dead by the 1980s. So explain that. I can't explain it. But there we are. It's the miracle of the automotive industry. Thank you very much. Any questions? I know we're running late.
Now, this is great. I have to make two comments.
Sure.
The first one is when you were talking about how essentially China, whether it's solar panels or lithium batteries, they are selling products at less than the cost of the materials.
Yeah.
It reminds me of this story about a Chrysler executive a long time ago who said, you know, we lose money on every car, but we make it up in volume.
Yes, exactly right.
And I want to understand, how long can it be that a state supports
They
a
can't.
money-losing
They can't.
industry?
So-
It can't go on forever.
You've heard in the last year the Chinese government has begun to clamp down on the automotive company, especially the 300 or so new entrants, 300 new entrants in EVs, beyond explanation.
Yeah.
And they said to them, no, we can't keep supporting you. You're going to have to sort something out, and you can't keep undercutting each other continuously. But it has happened. It has continued.
So that'll change in some.
It's going to have to change. They
The
can't.
other comment is just a piece of history, but when you brought up that 1977
Yes.
about the introduction of microprocessors.
Yes.
I can tell you that I grew up exactly at that time, and my graduate advisor was asked by General Motors to create a series of lectures that became a book called Understanding Automotive Electronics, where he spent a considerable amount of time educating managers and executives at General Motors on what a microcontroller is, because these were all mechanical engineers
Yeah.
who had graduated in the 50s, okay, and
Yeah.
60s, had absolutely no clue of what a microprocessor. So I'm just telling you that I grew up into that,
No, so-
joined the
so what was
vehicular electronics laboratory
What was the date of the book?
in 1980, give or take.
Right. So this is 1977.
I mean, he was doing, in the late 70s, he started doing these
Yeah.
training.
I'll send you
executive
this
training.
copy here and you should read it because it's absolutely remarkable.
Yeah.
So I'll read the last sentence. All agree that it will be expensive, but it's uncertain whether the expense will be justified by an improvement in vehicle performance. So, this was the beginning. Any other questions or observations, please?
I don't know which slide to go to, but it was a slide where you were plotting the likelihood of a fatality by model year vehicle.
Yes.
And it went back to, I believe, one more slide forward. Yeah, this one right here.
This is by VMT.
Yeah, okay.
So it's the same, let me just explain where it arises from. It's this data here, which is vehicle age.
Yep.
But then bear in mind that here, VMT of a new vehicle is 13,500 a year and it
Yeah.
drops to 500 miles only by year 20.
Okay, so just
So
going,
that's the factor of 25 comes out in the VMT.
Got it.
And the factor of 10 comes out because it's an older and shittier vehicle. To use that.
There is a technical term.
So if we go back to that particular graph there, then
That one.
yes, this one. So the question that I have is, do you think that this trend would hold if you shifted the data back and you were looking back to the, say, 1990s through, I guess in this time frame, it'd be the 1970s?
Yes, I'm going to do exactly that. I haven't done it.
Okay,
I don't believe that the data is as good back then.
Yeah,
as it is now. So I might be able to shift 10 years back or 20 years.
but my question was like, and the point I kind of wanted to get at is you show later on in your, you show later on in the presentation, the introduction of electronics and all the additional features.
Yes.
And there was, in my mind, a correlation potentially around the 2000s to 2010s with the introduction of greater electronics and active
Yes.
safety. So is this a
Well,
function of
it
vehicle?
was that, but I tried to, I interrogated ChatGPT and I said, tell me in every year what the most significant automotive improvement was. And I wanted to see a breakpoint around 2010. Turns out there isn't a breakpoint around 2010. All it would tell me was high strength steels, number one, and number two, multi-stage airbags. And I can't begin to believe that those two would lead to this need here. So I need to investigate exactly that. What happened between 2005 and 2010? Don't know.
Okay, that was the question and
Yeah.
observation that I had. Is this a function of vehicle age being the problem? Or is this the additional safety features that have been continuously added to the vehicles? And
It's exactly, so you've taken my one and number two there.
Okay.
And can't tease them out. And of course, there's driver capability. And we don't know what happens. Do older drivers drive older cars? I think they do, but I think younger drivers also drive older cars. So is there a bimodal distribution in driver age, let's say? And hence, as a proxy for capability, don't know. This needs much more work. But I tried to find this. I would have thought people would have looked at this and haven't. So, yep,
okay, thank you.
sure. Any other comments or questions? You have to stay here.
Just one slide.
Sure. So this is just the likelihood of a vehicle from any of these model years being involved
So
as a function of number of vehicles.
I haven't, it's late in the day, I haven't thought about this deeply, but could the year zero be lower just because on average a vehicle, a 2025 vehicle is only 6 months old at the end of the year?
It hasn't lived a year yet.
Yeah.
I get your point.
Yes, yes,
That
exactly.
first date,
It
is
is.
it higher?
No, you're quite right. But, and why you see this little wiggle here, don't know that.
No.
So ignore that, just by eye. It's just it's the gross trend that I'm mostly.
Yeah, but it maybe shift it down.
There's going to be little wiggles. Yeah. But again, it's the number of vehicles in the fleet that remain from that model year shrinks constantly over time. And then secondly, of those vehicles, they do less and less VMT themselves. So you get a double multiplier effect, which is that plus that. And-
Go ahead.
Sure. And intuitively, I've always thought along these lines. I had no idea that it was hundreds of times. Hundreds of times.
One last comment.
Sure.
Entire countries have not survived the crisis of the automotive industry. Therefore, there isn't a British automotive industry anymore. And the Italian automotive industry is on its way out. I mean, it's still in existence today as part of Stellantis, but every new investment in manufacturing plants is going elsewhere. So I think Italy is going the way of Great Britain, where the auto industry is going to disappear. Somehow Germany, the US are still surviving. France is still in there, struggling, but they're still in there. But I mean, will everything be made in China? It's an interesting question.
It's a very interesting.
Interesting.
The thing to bear in mind is that the United States is essentially an island. As you know, we export 100,000 vehicles a year to the Middle East, and that's it. So people say, well, we can't compete with China. We don't have to compete. We're an insulated
Captive
market.
market.
Yeah.
Outstanding, Chris. Thank you so much.
Thanks, everybody online.